Welcome friends, this tutorial has designed for 8051 based embedded system design with the Proteus and Keel. EDA stands for Electronic Design Automation. The emergence of EDA technology greatly improves the efficiency of the electronic circuit design and reduces the hardware cost and the labor of the designer. Here the outline. uh, What are the embedded system applications, design consideration, design methodology, design issues, hardware design challenges, component and structure, embedded system design example, real-time system, embedded system and EDA tools such as software design tool, hardware design tool. In next part of this tutorial, a demonstration will be shown on software development and simulation using Keel and a hardware design and system integration and testing using Proteus, and finally system PCB design using Proteus. So I'm trying to make it as student can grasp the concept. uh, Embedded system architecture, system component, design methods, EDA tool for embedded system. So this tutorial is introduced by separating the introduction of hardware and software and the system design methods. Application of embedded system in every field as shown in this pic. Uh, how can define the embedded system? There are the several ways. An embedded system is dedicated to perform a specific task, a control system within a system, the combination of hardware and software to perform a unique task, and they respond within a specified time limit. Uh, Other name is a real-time system. So bridge between VLSI and embedded systems designs. The VLSI design deal with the IC design, testing and fabrication, but embedded system deals with the application of ICs. So here's the characteristic of embedded system. Generally, they perform a single or unique task. That's why they are not general purpose. Right response at the right time. Other considerations are power, cost, size, and reliability. And hardware software development. Software development enhance the feature and flexibility. Hardware are used for performance and security. So embedded system are quite complex to design. Uh, so here the essential embedded design consideration. So first is the correct functioning is the crucial for the safety in critical applications. Otherwise damage to life and economy can be result, and not only right output but at right time. As embedded systems are reactive systems, so once started run forever, and termination is the bad behavior. Area should be small to make embedded system compact. Minimum cost make it easily accessible. Portability to use anywhere and anytime. Good throughput. Low power is essential for battery operated systems. Fault tolerance should be high. Time to market must be low. Throughout the design process of practice, top-down design method is adopted according to the different applications. The design process is basically divided into 5 steps, such as the requirement analysis, specifications, hardware and software building design, system integration, and system testing. So this process starts with the most abstract description of the system and then define the details. The requirement analysis determine the work which puts forward complete, accurate, clear, and specific demands to the target system. And specifications is the process where the refinings the needs. Next is the task partition. First divided hardware and software according to the function and then implemented software function by Keel IDE. Selecting electronic component involved in use by Proteus. drawing hardware circuit diagram as the virtual hardware circuit simulated by the embedded system. So loading the software into simulation circuit for system simulation in the design process. And the final is a system test, carrying out the system functional test and the procedure stability test by the register, simulator, simulation oscilloscope and other component in analog circuit. So design issue, hardware and software co-design. In traditional design, software and hardware partitioning done at an early stage so that the development proceeds independently. So in hardware and software co-design, uh, it allow hardware and software design to proceed in parallel with interaction and feedback between the two processes, so that evaluation of trade-offs and performance yield ultimate result. So next is the hardware and software partitioning. This is a tough job. So the choice between hardware and software is driven by consideration of speed, cost, need of the flexibility. Uh, so in fully hardware solution, uh, more speed, more cost, more time to market, and but they are less flexible. In fully software solution, the system are slow, less time to market, less cost, but they are more flexible. So hardware design challenges. Since a microcontroller in an embedded system will run just one program all the time, hardware resource must be matched to the needs of this particular application. Modern technology has made it possible to put the entire electronics, inclusive of sensor, analog circuit, digital circuits, on a single chip, or in other words, this is called a system on a chip. The degree of integration used with the depend on cost, need for a small size, availability of the components, etc. So last is the low power design, especially important in three cases. First, battery operated and mobile system such as portable MP3 music player, smart cellular phones. Second, the system with the limited power source such as the smart public pole booth which drives the power from the phone lines. And last one is the high complexity and fast system, in other words where heat dissipation is a problem. Okay, so the essential component of an embedded system, microprocessor, microcontroller, digital signal processor, depend on the application domain such as data processing or control, sensors to sense the real world, converter, analog to digital converter, digital to analog converter, actuators are the electromechanical parts or devices. So memory for permanent storage and temporary storage, to communication path with the interacting environment or human interface. So here the typically embedded system structure, sensor get the information from the real world, so and then analog to digital converter convert the information, analog information in digital form to process in digital device such as processor and ASICs. So processor processed data convert back into analog by using DAC and feed it into the actuator to respond. Okay, so here a task. The task is design an embedded system to protect a home from fire. So this is the requirement and the specification. The cause of fire may be smoke produced by the cigarette, short circuit, LPG leakage, etc. So after the detection of the smoke or LPG leakage, an alarm must be on. Uh, But if there is fire, a water fountain or fire extinguisher must be on. In order to detect smoke, LPG and fire, sensors are needed to warn and protect. Alarm, uh, motor control, fire extinguisher are needed to integrate them and process functioning, all functioning. Electronic controlling system are needed. So here the system block diagram look like as given below. Next task is write the software corresponding to the requirement. Okay, so Here the mechatronics. Mechatronics is the mechanical parts controlled by the electronic system, as shown in this block diagram. So here the example of mechatronics. Embedded system are the mix up of electronics and mechanical system, such as car in which an integrated control, communication and information system. Okay. The real-time system. The real-time system is a system whose specification included both logical and temporal correctness. So the logical correctness produces correct output, and temporal correctness produce output at the right time. Okay. So there are the two types of the real-time system: soft real-time system and hard real-time system. In soft real-time system provide a time guarantee, but missing an event is not a catastrophic. But in case of harder real-time system, when missing a timing deadline will lead to catastrophic result. Okay. So the tools of the trade. The Keel SDCC are a powerful C compiler, assembler, debugger, which support a large variety of processors such as JAT80, 8051 series, ARM series, AVR, PIC, etc. So, software development tool made easy to write software. For hardware design and simulation or system testing, we use Proteus, and other tools are Multisim and FreeSpace, etc. Okay. So here the advantage of the Keel IDE. The software design is built by the Keel Integration Framework platform. The Keel IDE is basically an assembler and a compiler, or whatever we name it. We can also use single step execution tools and software simulation tools to observe the operation of the program and the content change of registers, the on-chip RAM, and the chip on-chip RAM, off-chip ROM, or on-chip ROM with the program running. We can write either an assembly or C language code, and Keel will take care of the rest for us. Furthermore, it supports many of the 8051 and ARM variant that we will fix. So next is the Proteus. Proteus is a simulating software, but it helps you attach many components with the 8051, like resistor, capacitor, LEDs, LCDs, keyboard, keypads, ICs, etc. It has a complete library, and we will find everything that we ever need. We can design our complete circuit and then simulate it. Then can simulate it to view the final output. This means uh, after perfecting our project on the programming side in Keel, we will need to simulate it on Proteus to determine the output of the hardware component, and can change it to achieve the target specification. So after the simulating our circuit design in Proteus, we can directly make PCB with it. So it could be all in one package for a student. Mm. So here the future direction for the developers. Ah. So embedded system will be developed in unusual application, such as stress detector built into walls, powered and accessed by radio frequency beams. Okay. So more and more multidisciplinary expertise will be required. For example, biology, chemistry, electronic, and VLSI for biosensor. Okay. So here, how can we place in EDA bridge? It's all about us. Uh, VLSI design, front end part, VLSI design back end part, MATLAB and Simulink, image signal processing, or embedded systems, PLCs. So here about myself and my friend. So thank you. Have a nice day.